All right. So while we're waiting, we'll get started on this. Now, today, the plan is we're going to have the chapter 3 practice problems number 2, which we didn't quite finish last week. Actually, this one we didn't start. And then we're going to go over the sample midterm. Okay. And when that's done, then we can go ahead and do the rest of chapter 4 if time permits. Okay. So we already did last week the chapter 1 and 2 problem sets and the first of the chapter 3 problem sets. So this is the end of the problem sets, except for the sample midterm, which we'll do after this. Now, when that's all done, that means we're completely ready for the first midterm, which is completely based on chapters 1, 2, and 3. So because we only meet once a week, planning this is very, very awkward. So I was thinking that what we should probably do is have it next week, next Wednesday, which is the 16th, just to get it over with. And then we can carry on with where we left off in chapter 4 and then dive into chapter 5. Now, the second midterm is based on chapters 4 and 5. So not that it's imminent, but, we're getting closer to the second midterm as well. So, time is flying. It seems like we just started, but in reality, this is already the 6th week of the semester. And so the first midterm is almost upon us. And then the second one will be fairly shortly after that one. The final will be sometime in May. The final, by the way, will not be comprehensive. It'll just be the last 2 chapters, which are 11 and 12. All right, then. So let's start. So what do we have here? Quadratic functions. We want to rewrite these in the so-called vertex form. Now, you might recall that the vertex form looks like this. We have, first of all, with a quadratic function, it can be described as a parabola. And if it's facing up, the vertex is the minimum point. And that occurs, of course, when the parabola, the quadratic equation rather, which is always written as y equals ax squared plus bx plus c. If a is positive, then the parabola faces up. The vertex is therefore the minimum point. If instead a is negative, then the opposite happens. Okay, so in other words, if the parabola has a negative a, or actually if the equation has a negative a, then the vertex is the maximum point. All right, so obviously one or the other has to be true in each case. So what we're trying to do is rewrite the equation in a form that makes it easier to see at a glance what the vertex is. Okay, so the correct formula is here. All right, so the question is, how do we get it into this form? Now, of course, it's just an equivalent way of doing the same thing. It's just that there are reasons why this might be more helpful. The vertex, by the way, is actually the point h comma k. So here's the x coordinate and here's the y coordinate. All right, so the question is, how do we find this? Well, it turns out that really all we need to do is plug in what we have into a formula. Now, first things first, let's go back and look at the original equation. Oh, actually, here they are, sorry. They're down here. The equation that we'll be looking at first, right here, remember the way this works, y equals ax squared plus bx plus c. A is 1, because there's an implicit 1 here. B is negative 12, and C is 32. All right, then. So the formula looks like this. H is negative B over 2A, which in this case is negative 12 over 2 times 1, which is 12 halves, which is 6. All right, and then once we have that in place, it's easy to calculate k because k is simply f of h, okay? So in other words, remember, this function is x squared minus 12x plus 32, which means that what we're looking at is f of 6, which is therefore 6 squared minus 12 times 6 plus 32, all right? And that equals 36 minus 72 plus 32 minus 36 plus 32 minus 4. So that tells me that the point that we're looking for, the vertex h comma k, is the ordered pair 6 comma negative 4. And because a is positive, that indicates that this is the minimum point on the parabola, which we can sketch here. We don't know exactly what it looks like. We know that it's facing up though, because a is positive 1. It's greater than 0. So let's say that it's here, 6 comma negative 4. But as far as the question goes, what we're really being asked to do is take the original equation and write it in this form. Okay, so when we do that, we have f of x equals, so remember up here we define a as 1, okay? Then we'll have, so we don't need to write it, x minus h, which is 6 squared, plus k, which is actually negative 4. So this is the so-called vertex form. And of course, it represents the same parabola, the same quadratic function. What's different is that you can see at a glance that the vertex has to be 6 comma negative 4. This is minus h, this is k. And so the vertex is 6, let me write it like this, h comma k, which means 6 comma negative 4. All right, now they're all done in exactly the same way. So a is 1, b is 2, c is negative 3, okay? All right, remember there's an implied 1 here. And so what we're looking for is h is negative b over 2a rather. And when we plug in those numbers, we'll get negative 2 over 2 times 1. Negative 2 halves is just negative 1. And k is easy because k is simply f of h, f of negative 1. And since this is our original function, that means we'll have negative 1 squared plus 2 times negative 1 minus 3, 1 minus 2 minus 3, 1 minus 5, negative 4. All right, so that means that the vertex is so because the function, the vertex form is written as a x minus h squared plus k. You can rewrite this as, remember, a is 1, x plus 1 squared minus 4. All right, so it's just really a question of being very careful with the negatives, okay? Now this one is a little unusual because, well, the constant is 0. It's not that unusual, but just keep in mind that a is 1, b is also, well, b is negative 1, and c is 0. So h is minus b over 2a, minus 1 over 2 times 1, all right, 1/2, just leave it like that. And therefore, k, f of h And so that's going to be a half squared minus a half, which is a quarter minus a half. And I can rewrite this as a quarter minus 2/4, negative a quarter. So therefore we have as our vertex 1/2 comma negative a quarter. And therefore the function in the vertex form, that is. And once again, just by a ridiculous coincidence, a was equal to 1. So we just need x minus a half minus squared rather minus a quarter. All right. Looks like there's one more. So once again, a is 1, b is 5, c is negative 2. All right, so h is negative b over 2a. All right, minus 5 over 2 times 1, minus 5/2. And then k will be f of h, or f of negative 5/2. So I'll go back to this equation and replace all the x's with negative 5/2. Negative 5/2 squares plus 5, negative 5 over 2. 25/4 minus 25/2 minus 2. So the common denominator here is 4. And that's their best choice, I think. 25/4 minus 50/4 minus 8/4 would be minus 33 over 4. That's our k. All right, so we have minus 5/2 minus 33/4. And so when we go to write that expression again, a times hold on one second. I'm just double checking something. A times x minus h squared plus k, when we substitute, we get, and again, a was, oh, okay, hold on one second. That's one of the annoying things about this tablet, this marker. It has buttons on it that do nothing useful except cause problems. So we'll have a is 1 again, so we'll just have x plus 5/2 squared minus 33/4. And so as a result, well, that's it, we're done. Okay, that's our vertex form. All right then. Now here we're looking for the minimum or maximum point and the axis of symmetry. Now, what is the axis of symmetry? All right, well, again, just remember, the vertex is either the minimum or the maximum point, depending on whether the parabola is facing up or down. So this, let's say this point is the vertex. The axis of symmetry is this. It's just basically the vertical line that cuts through the vertex. So what we're looking for here is basically the vertex and the axis of symmetry. So this set of questions is not much different than what we were doing just a few minutes ago, except for that addition of the axis of symmetry. We're still looking for the vertex. Okay. Now, like in a case like this, the vertex is the minimum. There is no maximum in this case. Okay, because the parabola goes up to positive infinity. When we have this situation, let's say our vertex is here. Well, it's not drawn as well as it could be, but let's say that's our vertex. Well, this point is the maximum. There is no minimum because the function will continue all the way down to negative infinity. And so therefore, you can't have both. There's not going to be both a maximum and a minimum. It's either one or the other. And that in turn is simply equal to the vertex. And then again, the axis of symmetry is just simply the vertical line that cuts through this vertex. So for example, here, f of x is 2x squared plus 10x plus 12. A is 2, B is 10, C is 12. So remember the H is negative B over 2A, negative 10 over 2 times 2, negative 10 fourths, which we can obviously simplify as minus 5 halves. And then K is f of H. So it's 2 minus 5 halves squared plus 10 times minus 5 halves plus 12. Now again, we're going to need a common denominator here. It'll probably end up being quarters. When you square 5 halves, you get 25 quarters. This time we'll have minus 50 halves plus 12. All right, well, it looks like we were right. We're going to have some quarters in there. So what does that give us? 50 fourths minus 50 halves plus 12. So let's turn them all into quarters. All right, so minus 50, that's minus 2 fourths, which is minus 1/2. Okay, so your vertex is minus 5 halves, comma, minus 1/2. And since A is positive, right here, A is 2, so that's a positive case. That would be this case on the right. That means this vertex is the minimum of the function. Okay, so since A is positive, this is the minimum of the function. Minimum in the sense that y can't get any smaller than that. Okay, now what about that axis of symmetry? Well, again, remember, all you're trying to do is find a line that cuts through that point. And so what you're going to do is just say, well, therefore, x equals, and you're just giving it minus b over 2a which is minus 10 over 2 times 2. So basically what you have here is a vertical line which cuts through the axis, the vertex rather. And so what you essentially are doing here is telling, or the answer is the x coordinate of that vertex. Okay, so in other words, it's no coincidence that it's negative 5 halves because that's just the x coordinate here. Or given that we're writing it as h comma k, you can think of that as h. So basically, you're just saying x equals h here. And then if you drew that line, the line x equals negative 5 halves is a vertical line. That's all it is. So basically, you've got your parabola, Well, okay, let me fix that. I have to make sure it's negative, otherwise it won't look right. So this is -5/2, comma, -1/2. And the axis of symmetry is simply the vertical line. X equals -5/2. That's all it is. And even though it's not drawn as well as it might be, what it means is that if you were to visualize, maybe I can straighten that out a little, what's on the left and what's on the right should be mirror images of each other. Okay, so in other words, this, although it doesn't, is supposed to exactly match this. And that's why it's called the axis of symmetry. Oh, look what I did. Oh, no, that's right. It's fine. Okay, it's not perfect, but you get the idea. All right, so like I said, it really is just a simple extension of what we were doing in the first part. All right, what's going on here? A is 2, B is -10, C is 4, and of course, what are we looking for? H is -B/2A. And that would be -10 over 2 times 2. 10/4 is 5/2. K is f of h, which means you'll have 2 times 5/2 squared minus 10 times 5/2 plus 4. And so we'll end up with 2 times 25/4 minus 50/2 plus 4. All right, so I'll have 50/4 minus 100/4 plus 16/4. You have minus, let's see, minus 50, minus 34/4, which you could then simplify, if you want to, as minus 17/2. Okay. Okay, so now what? Well, what we're going to need to do is find K. Okay, so how do we do that? K, of course, is f of h. So the original function way back up here, let me split the screen for a second. We're going to have 2 times minus 17/2 squared minus 10 times minus 17/2 plus 4. All right, well, this will be no fun, but we'll get it. All right, so we've got 17 squared is 289, as it turns out. 289 over 2. 4 rather. Okay, sorry, I almost blew it. 4, because we're squaring both the numerator and the denominator. Minus, or plus, actually, in this case, 170/2 plus 4. And then, what are we going to get? Oh, what am I doing? Am I doing it twice? Hold on. I think I did something wrong here. Oh, I just realized, what am I doing? I'm trying to do the same one all over again. Hold on. Nope, sorry. I was looking at the wrong thing. Sorry, this is not correct down here. It's already finished. It's the axis that we're looking for of symmetry. All right. So there's no point in doing work twice, is there? No. All right. So yeah, we're all set here. We've got h is 5/2. Let me just write this down. H comma k rather, h comma k. So basically, I mean, it's pretty straightforward. You can see that the axis of symmetry is just x equals 5/2. You don't really, there's really nothing else you have to do. Once you've got the vertex, the axis of symmetry is essentially just saying, what is the x coordinate? That line is the axis of symmetry. So that's all there is to it. It's not much of an extension. All right, now what about these two? All right. So we'll start out by noting that A is -1, B is 4, C is 3, which means that H is minus B over 2A minus 4 over 2 minus 1 minus 4 over -2, which is just 2, of course. All right. Now, how about K? Minus 2 squared plus 4 times 2 plus 3 minus 4 plus 8 plus 3 is 7. That's your vertex and the axis of symmetry. Is therefore x equals 2. All right, x just equals the x coordinate or the h. All right, then one more. Here we have A is 4, B is 1, and C is -1. So H is -B over 2A, which ends up giving us -1/8. All right. And what does that tell us about K? K is f of h. We'll have 4 times -1/8 squared plus -1/8 minus 1. Four times 1/64 minus 1/8 minus 1. So let's have a common denominator of 64. All right. So that should be, wow, 68 over 64. What does that equal to? You can actually reduce that if you divide the numerator and the denominator by 4. You actually wind up, wait a minute. This is minus, sorry. All right, now we're good. Okay, so in other words, h comma k is -1/8 comma -17/16, which implies that the axis of symmetry is therefore x equals -1/8. All right, because again, remember that's the coordinate of x right here in the vertex. All right, now, how about these? What do we do about the domain and the range? Now, how does this work again with quadratic functions? The domain is always plus and minus infinity. Because the domain represents all the values of x that can go into this function. It doesn't matter what it is. This is going to be something like this. It's a parabola. And so there's no value of x that cannot be substituted into this. But when it comes to y, there's some minimum value. The vertex tells me its minimum value. Now, that would be this k. So as far as the domain, sorry, the range is concerned, when we note that a is positive, turns out that the domain, or the range rather, starts with f of -b/2a, and then it can go up to positive infinity. And this should not surprise you because this is how we calculated k when we calculated the vertex. Okay, that's what it is. So basically it's saying that y's value starts at k and it works its way up to infinity because the parabola is facing up. So in this case, we're going to have, actually, let's figure out f of -b/2a. Oh, and also while we're at it, we might as well identify the fact that a is 1, b is 6, and c is 4. All right, so f of -b/2a is the same as f of -6/2 times 1, or f of -3. And then that indicates that we have -3 squared plus 6 times -3 plus 4, 9 minus 18 plus 4, and that's going to give us -5. So therefore, the range of this function is everything from and including -5 up to infinity. Okay, so in other words, that would mean that k is -5, and then we can work our way up to infinity. Okay. Now, next, we have another quadratic equation, and a is 2, b is -4, and c is 2. So what are we trying to find out? Well, again, the domain is -infinity up to positive infinity. That's not going to change. Because a is positive, that means that the range, same thing, f of -b/2a, comma, infinity. Because we're looking at a parabola that faces up. Okay, so f now -b/2a is -4 over 2 times 2, 4/4, which is 1. F of 1 is 2 times 1 squared minus 4 times 1 plus 2. 2 minus 4 plus 2, what do you know, is equal to 0. Interesting. So therefore, the range is just everything from 0, including 0, up to infinity. Okay, notice the parabola sits exactly on the horizontal axis. Okay. Now, what's next? So here we have A is 3, B is -6, C is -9. So again, the domain, very simply, it's negative to positive infinity. The range, on the other hand, of course, because A is positive, is this. All right, great. Minus B over 2A minus a -6 all over 2 times 3. Oh yeah, here we go, 1. F of 1 is 3 times 1 squared minus 6 times 1 minus 9 is 3 minus 6 minus 9, or minus 12. All right. So that means that the range, of course, is everything from minus 12 up to, including, that is, infinity. Okay. All right, now there should be one more, and then we can do something different. A is 2, B is 6, C is -3. Once again, A is positive, so the range is this. All right, so let's see, negative B over 2A in this case. -6 over 2 times 2. And therefore, f of -3 halves is 2 times -3 halves squared plus 6 -3 halves minus 3. So obviously we're going to have a common denominator of 4. So let's do that. Oh, wait. Yeah, that's right. All right, so that's going to give us 18 minus 36 minus 12 is minus 30 over 4. And you can certainly simplify that a little bit by turning it into minus 15 halves. And so that means that the range is -15 halves, including -15 halves, all the way up to infinity. All right, now the next batch, these are going to be a little different. We're doing quotients and remainders. Okay, so let's do this. Now remember, this is very similar to long division. Now, one thing I have to watch out for with this tablet, the problem with writing with it is that it sucks up an awful lot of memory. So here's what I'm going to do, just to avoid any problems. I'm going to create a new document. I just want to split this up into 2 documents, just because if I run out of memory, it'll really be a nightmare. So let's use the rest of these in a separate document. So here's what you're actually doing. This is just like long division. All right, we're dividing x minus 1 into x squared plus 5x minus 1. So I'll have x, which when multiplied by x minus 1 gives me x squared minus x. Whatever that is, I'm subtracting the entire expression, which means this is now negative and this is now positive. These cancel. And I've got 6x minus 1. So what I'm going to do is put plus 6 here. And when I multiply that by x minus 1, I'll get 6x minus 6. When I subtract, I've got 5. So what that means then is that this expression, when divided by x minus 1, equals x plus 6 plus 5 over x minus 1. All right. The remainder is 5. The bottom line is that this is the remainder. So the quotient is x plus 6. The remainder is the 5. Right? That's your remainder. That's your quotient. All right. Now, of course, sometimes you have no quotient, no remainder at all. That's always very satisfying, but it often does not work out that way. Not with polynomials. So let's try this one. All right, so we have 4 here, 4x rather, which when multiplied by this expression gives me 16. Oh, actually, no, I don't want that. I want x, just plain x. I want to get rid of this 4x squared, whatever it takes. So we'll try that. 4x squared plus 2x, subtract the whole thing. Let's drop out. It becomes negative. And now I'll want minus 3, because that would give me minus 12x minus 6. Subtract, this is now positive, this is positive. So end up with a 12 here. And so once again, this ratio equals x minus 3 with a remainder of 12, which means it's 12 over x minus, sorry, wait a minute, no. Did it wrong, no. It's equal to x minus 3. Okay. Oh, no, I had it the first time. It's okay. No, I know what happened. I'm sorry, I copied it wrong. No wonder it doesn't look right. All right, let's try that one more time. We're dividing by 4x plus 2. Now that looks a lot better. Okay, so x minus 3 is the quotient. Remainder is 6, but that 6 is divided by the same thing we have over here, 4x plus 2, not this, x plus 2. So this is my remainder. Just the 6 is the remainder. Okay. Much better. All right, here we go. So now hopefully, at least one of these, oh, maybe we will have one without a remainder. That might be nice. Okay. So here's what we're doing. X minus 5 is divided into 2x squared minus 9x minus 5. So first we'll start with 2x, so that this becomes 2x squared minus 10x. Now I subtract. I change the signs. This is negative, they drop out. This is now positive. Oh. Well, that worked out rather well. Then when I have x minus 5, and it was 0. Oh, beautiful. So in other words, 2x squared minus 9x minus 5 over x minus 5 is equal to 2x plus 1. And the remainder is 0. Also, I just want to point out that implies too that x minus 5 times 2x plus 1, you can apply FOIL here and discover that this product does in fact equal 2x squared minus 9x minus 5. Okay. How about this one? All right, so let's try 3x over here. So 2x plus 14, well, what do you know? It looks like we have another case. With no remainder. All right, beautiful. So the quotient is 3x plus 2. Remainder is 0. All right, now finding the inverse, this is something we've done before and we're getting pretty good at it, I think. Y equals, let's rewrite this as y equals radical 2x plus 1. And remember what you're trying to do here. The strategy is to first reverse the x's and y's and then solve for the new y. Okay, so in other words, you can rewrite this as reverse the x's and y's, and now solve for y. All right, so square both sides. Okay, so then I'll have x squared minus 1 is 2y. And so my final result will be x squared minus 1 over 2 is y. This is the inverse. Or you could rewrite it as f inverse of x is x squared minus 1 over 2. Now, of course, you can prove it. It didn't actually ask us to do that, but you might recall that what you're doing is you're taking f of f inverse of x and f inverse of f of x and making sure they both equal zero, x rather. If they do, then you've obviously done it correctly. If not, well, that means you have to start all over again. Something obviously went wrong. Okay, here we go. Let's look at these. Now, these can get terribly, terribly messy. We'll try to avoid having any that are ridiculously complicated because, I mean, you get the idea. But, you know, you never know what can happen. In principle, I mean, not every function can be inverted, by the way. If there are holes in either the domain or the range, you may not be able to invert the function. So just be aware of that. It's not necessarily true that every single function is invertible. So I'll try to avoid having any of those, but in those cases, the answer would be that the inverse does not exist. All right, so we're almost there. X squared minus 3 over minus 4. And you can just leave it like that. I mean, you know, usually you see the negative moved out here, but it doesn't really matter. Okay. And you can see these are fairly similar to each other. So again, reverse the role of the x and y. Now we have to square. And then we divide out the 4. All right, x squared, x minus 9 squared plus 4 all over 4, and we're good. And finally, we have this one. And once again, I'll reverse the roles. And now we need to do some algebra, of course. And then we'll square both sides. Add 8. We'll divide by 6. Okay. All right, so that's that for the chapter 3 problem set number 2. So I think I did the right thing by saving this in 2 pieces because it looks to me like it was already running out of memory. So, all right. So by the way, of course, I will post these on Moodle as soon as we're done. And oops, let's get the other one going. So now we still have to do the sample midterm. And of course, here we've got a little bit of everything all jumbled together, which is part of the challenge because that's how we make sure we remember everything. So let's see what we can do here. All right. The slope of a vertical line is undefined. All right, why is that? Because if you look at it, that would be something like this, x equals 3. And it just means that no matter what points I pick, let's say 3, 3, and 3, 1, the slope is m equals delta y over delta x. But if you notice what's happening here, the x's aren't changing. So you've got, let's say this is x1, y1, x2, y2. Sorry, x2, y2. The difference in the y's is -2, which is fine, but we've got no change in the x, 0. So therefore, we have an undefined slope. Very good. All right. What is the equation of a line written in point slope form? That would be this one. Y equals, y minus y1 equals m times x minus x1. And that's it, okay? And you can tell because it has a single point, y1, x1, and the slope. The complex conjugate of 3 minus 4i would just be 3 plus 4i. Okay, so whatever you have as a starting point, you just change the sign, and that's your complex conjugate. Now, here's an interesting one, I to the 7th. Now, what if you forgot how this works? Well, you know what? First of all, just remember, I is radical 1, -1. Which tells me that I squared is -1. I cubed must be -i, because you're multiplying I times -1. I to the 4th is I squared, which is 1. And then the cycle starts all over again. I to the 5th is equal to I, which in turn equals the square root of -1. Because all I've done is multiplied I to the 4th by I. I to the 6th would have to be, therefore, when you multiply I by itself, it becomes I squared, which is -1. And I to the 7th, therefore being -i. And -i, and then finally I to the 8th would just be -i. Sorry, -i squared, which is +1. All right, so the thing to notice here is that this cycle keeps repeating itself over and over and over again. We go through the cycle I, -1, -i, +1. Then we start all over again. I, -1, -i, +1. So if you forget, all you have to do is go and write these down, and you'll see that, oh yeah, it must be -i. Okay. You know, well, because the thing is, if you put that in your calculator, you're not going to get anywhere. You have to reason this one out. But the way to do that is to think about the properties of I. All right, then. Now, how's the axis of symmetry defined for a parabola? Well, we just got through seeing plenty of these questions. The axis of symmetry is x equals -b over 2a. Okay. Because that's the y, that's the x coordinate in the vertex. Beautiful. Now, what is the domain of a quadratic function? Well, we know already. It's negative to positive infinity. Now, all I need I hope the symbol's there. If it's not, here it is. Here it is. All right, great. Now the range of the absolute value function, that's an interesting question. Now you know, it's one of those things you can try to memorize one of these. But you know what, there's no reason to, because if you draw a picture of this, basically what you're seeing here, remember the range is the possible values of y. So therefore, with this type of function, y can be 0, and anything positive, it can never be negative. So what you're going to end up with is range is 0, comma, positive infinity. Okay, if you notice, I've put a square bracket there next to the 0 to remind us that 0 is included in this. Okay. Now, a one-to-one function. Now, this is going way back to day one, basically. This is a function where each element of the domain, meaning the x values, is associated with a unique value of y. So if you drew a little picture of this, like we did way back in the beginning, it means that, for example, you have something like this. Not only is each x associated with exactly one y, but each y is associated with exactly one x. Okay, so that would be one-to-one. Whereas something like this, this one is not one-to-one, because the y equals 5 does not have an x associated with it. It's still a function because each x is associated with one y. It's just that this y is missing an association with x. Okay. All right. So, and by the way, if you get stuck explaining this in English, you can certainly draw a picture. Now, the reciprocal function is y equals 1 over x. Okay, so what does that thing look like? Well, remember, if as x gets larger, y gets smaller. If x is negative. Now, if x is, if it's positive, if x is negative, y is also negative. And it's the same idea, except that as, you know, let's say x is -1, its inverse is -1. And then it increases. So the domain, and this drawing is not necessary. All that matters is that you notice is that x cannot equal 0. And so all you have to do is show that the domain is -infinity up to 0, but not including it, and then 0 up to positive infinity. And you're done. Okay, that's how it's written in this form with sets. Okay. Now, what kind of function has the property that for every x, f of x is f of negative x? Now, you might remember, and this is going way, way back, this is known as an even function. Okay. If you're not sure, go back to chapter 1. You'll see that there's an even function and an odd function. The odd function, if you recall, is this one. Okay, so this one is even. So now let's go look at it. We'll get chapter 1. You know, sometimes these search engines, I'm telling you. All right, possibly it was chapter 2 then. Okay. Well, you know what? I'll tell you what. I'll look for it later on. So, all right, let's get back to this. I'll find this references to it. All right, now, if two lines are perpendicular, what is the relationship between their slopes? Their slopes have a product of -1. That's how you can tell. Okay. How about this quadratic function? What is the range? Well, you recall that we did this just a little while ago. A is positive. Okay, so A is 3, B is -2, C is 1. So this is a third. So f of 1/3 is what we're looking for. Okay. All right, so this time it looks like we'll have thirds. Two-thirds. Okay, so that tells me that the range is very simply, including 2/3, up to infinity. Okay. I just want to double check it for a second. 3, -2, 1. Right, 1/3. Yeah. Okay. Yes, that's correct. All right, now, determine if it's a function. Well, this is something, again, going way, way back to the beginning. And so, remember the way this works. You're trying to make sure that each x goes with a single y. Each y, rather, goes to a single x. So the way you could formally define this is to say, yes, each element of the domain, which in this case is the entire real number line, is associated with a unique element of the range. Okay, so for each x, there's a single y, and that's it. Now for these, well, it may not be true. Let's see, what do we have here? Why don't we draw this out? -1, 0, 2, and 3. What do we have over here? 1, 2, 1, -2. So let's see, 2 goes with 1, 3 goes with 2, -1 goes with 1, and 0 goes with -2. Okay, so we're good, because in other words, every single one of these x's is associated with a unique value of y. Or another way to think about it is that there is no x which is associated with two y's. Okay, so the same thing holds here. And keep in mind too, the way I've written this is the domain. And this is the range. And you can think of this as f of x. Whatever x is, we associate it with a single y. Now, how about this one, though? So the x's are 1, 0, negative, here we go. The y's are 1 and 2. All right, here we go. 1 is associated with 1, 0 with 1, -1 with 1, 1. See, here's the problem right here. 1, x equals 1 is associated with both 1 and 2. That's where the problem is right there. That is what means that it's not a function. So the answer is no, because x equals 1 is associated with both y equals 1 and y equals 2. It'd be like the same person having two different social security numbers. That's really what it amounts to. That's why it can't be a function. All right, and now what about this one? So for the x's, we have 0, 1, -2, and 3. The y's, we have 0, -2, 1, and 3. Yeah. All right, so 0 goes with 0, 1 goes with -2, -2 goes with 1. And well, do you know, this one is fine because each x is associated with a unique value of y. Okay, in other words, none of the x's are associated with 2 or more y's, and that's all that it takes. All right, so those are done. Now down here, domain and range. So basically, what we're after here is we're trying to figure out the domain. It turns out that x cannot equal 0. So therefore, the domain is everything from -infinity up to 0, union 0, +infinity. The range is trickier, but when you have a ratio like this, what we note here is that no value of x will result in y equals 0. And so therefore, they're both the same. Everything except 0. In fact, when I drew it earlier, there's actually both a vertical and a horizontal asymptote. In fact, why don't we consult with Symbolab and take a look at it? Oh no, what is that? Gotta watch it when you type in the internet. Just one wrong letter, it could send you to someplace very bizarre. Now, the nice thing about Symbolab is that it's already going to give you all of this information, but it'll help us to be able to see why by looking at the graph. And just as we suspected, the red lines are asymptotes in this website. So you can see that there's no value of that. I mean, x cannot be 0 because that would cause division by 0. But in addition to that, there's no value of x that we could plug in here and come up with y equals 0. So there's actually 2 asymptotes, and that's why 0 cannot be in either the range or the domain. Now, I don't know what this means, interactive graph. Oh, I guess I see what it means. I like this one better. This one is fine. I can actually see it. Oh, that's not what I wanted. Hold on. No, that's all right. We get it. All right. Now, what about this one? Well, first of all, x must be at least 2 to avoid the square root of a negative number or an imaginary number. But what about y? Well, the way it's written, y cannot be negative, can it? Because we're taking a square root. So that indicates that the domain is everything from 2 to infinity, including the 2. And the range is everything from 0 to infinity, including the 0. So let's take a look and we'll see why. Radical x minus 2 And there you go. In other words, the function starts at 2. Right here, x cannot fall below 2, y cannot fall below 0. Okay. It doesn't show as asymptotes on here. It just means that those are the starting points, the minimum values, after which everything is okay. Nice. Now, what about this one? Well, clearly x can't be 3. So the domain is everything up to and not including -3. And just like we saw before, there's no value of x at which y equals 0. And so therefore, the range is -infinity up to, but not including 0, combined with 0 up to infinity. So those would be our asymptotes, by the way. The horizontal asymptote is y equals 0, or in other words, the x-axis. The vertical asymptote is that x equals 3. So let's go back to Symbolab. And of course, it will tell us everything we need to know. Okay, so yeah, I mean, you can see the domain, everything except 3, the range, everything except 0, and the graph shows us y. There you go. X can't be 3, y can't be 0. Beautiful. Now look at this one. This is the cube root of -x. So this will be something like this. I think. All right. It's either that or the reverse. Let's just go look here. Y is negative. Okay, it's a cube root of -x. Oh, I got it backwards. Okay, it's that one. Now look how easy that is to fix. But when you see it like this, it should be clear that there's no value of either x or y that's going to cause a problem. So the domain and range are all real numbers. Okay, there is no value of x that would cause an issue, and any value y is possible. All right, so yeah, and it'll tell us here right there. Yep. Okay, great. Now the average rate of change. Now we did this fairly recently, as a matter of fact. It's a very straightforward idea, but let's review it real fast. Here's we've got 2 points. Now keep in mind, this is not meant to be an ordered pair. These are 2 different values of x. Okay, so think of this as x1 and x2. So this is basically what you're looking at here. Hold on 1 second. I still didn't quite get it. It's supposed to touch. Oh, there you go. Beautiful. I can't do that on the board, can I? No. So the values they're giving us, x is -2 is here, and 8 is here. when x is negative 2, f of x or y is going to be 24. And for the second point, 8, f of x2 is 6 times, oh my God, 384. So we're looking at the average rate of change, which means the slope of this line that connects the two of them. Okay, so you're connecting the point -2 comma 24 with the point 8 comma 384. So now you're basically doing the slope. I mean, the formula looks very mysterious, but it's just the slope of the line that I've just drawn here. It's the secant line actually to this parabola through those 2 points. So think of this as x1, f of x1, x2, f of x2. And the formula actually says to do this. So I'll have 384 minus 24 over 8 minus a minus 2. (360 over 10), 36. Okay, so they're all exactly the same. So once you get the hang of it, it's really not hard. It's always the exact same procedure. It's just a question of, not making mistakes algebraically. So let's see what we have here. F of x1, or sorry, x1 is that first term there. F of x1 would be -8 squared over 4 minus 8. (64 over 12). Okay. And then x2 is -5. -5 squared over 4 minus 5. 25 over 9. So the formula is telling us to do this. Well, now, that's going to be tricky to combine. So let's see, what can we do? 25 ninths and 64 twelfths. Well, you know what you can always do? You can always use one of them as the common denominator. That might help. All right, so 25 times 12 is 300. Oh, I almost forgot. Sorry, this needs 9 over 9. Otherwise, we're not doing anything here. Over 108. And 9 times 64 is minus 576. Man. Oh, also, I just realized this is not 13, it's 3 because it's -5 plus 8. So this is -276 over 108 over 3. Algebraically, this is the same thing as -276 over 324. And if you want to look for a common denominator, if you divide them both, and you don't have to do this, but you can divide them both by 12. And if you do that, that's one common factor they do have. So if you do that, you'll end up with -23 over 27. Okay, that's as small as it's going to get. All right, let's just double check that. Yeah, that's good. Hopefully some of these are less messy. All right, now let's look at this one. x1, -3, f of x1, 7 plus 4, -3 squared, 7 plus 4 times 9, 43. x2 is 3. Oh, it's the same. Now, you know what that means. We don't really have to go any further. Because, remember, the numerator is the difference between these f of x's. So in other words, -43 minus 43 over 3 minus -3. It doesn't really matter. It's just 0. All right, now this one, x1 is 0. F of x1, 5 radical 0 minus 2, 0. It's just 0. Great. x2 is 5. F of x2, 5 radical 5 minus 2 times 5. Now, that's not exactly a nice number, but we can work with it. So the change is okay, 5 radical 5 minus 10, all minus 0, divided by 5 minus 0. Okay, this might turn out okay. So we have 5 radical 5 minus 10 over 5 is radical 5 minus 2. That's it, we're done. Okay, so that turned out to be less painful than we anticipated. Okay, so you can see what's coming up next. We're going to be doing some functions. We're going to consolidate functions, and then we're going to do some, ooh, man, there's a lot here. All right, well, it is, after all, a review for the midterm, but why don't we do this? Let's have our break right now. And when we're done, say we'll come back at 5 o'clock, and we'll go back to these composite functions. Okay, all right. Well, here we go. So for these functions, we're going to do the standard algebraic operations on them. These are pretty straightforward. It's the composite ones that are really kind of difficult sometimes. But all right, let's see what we've got here. So here you're just literally adding them together. Okay, so you drop the parentheses, x squared minus 3x plus 5 plus x. Let's rearrange them a little bit. And we finally end up with x squared minus 2x plus 5. And it was just that simple. Beautiful. All right, now subtracting, of course, there's always a risk. You're going to make a mistake with the sign. So let's do this. I'll put these in parentheses. Okay, so then we'll drop the parentheses. Yes, drop the parentheses, but make sure you apply the negative sign here. All right, and then of course, that's where the most likely problem will be. So when we consolidate these, we'll end up with our correct answer. X squared minus 4x minus 5. All right. Now, for multiplication, now in a case like this, you might as well use FOIL because they're both binary expressions. You've got x squared minus 3x times 5 plus x. All right. So F, O, I, and O can be written as, here's our F, 5x squared. O is x cubed. The inner ones here are minus 15x. And then last would be minus 3x squared. So here you do have to consolidate some of these at least. It doesn't always work out that way, but this time there's two terms that have the same exponent. So we'll have this one and this one. And of course, we always want to write the exponents in descending order. So in other words, these two add up to 3x squared. Almost, sorry, I almost messed it up. This x cubed has to come first because that's the highest exponent. Then we can consolidate these two plus 2x squared. Then we can get to the minus 15x. Okay, great. So it's not that it's wrong if they're not in that order. It's just that that's how it's normally done. By convention, we try to have, for any type of polynomial like this, the highest exponent is first, and we work our way down to the lower exponents. Now, for this last one, there's no guarantee that we'll be able to simplify this. In fact, we often are not able to. Hold on. Let me just split the screen. You can see what we're doing. All right, here we go. All right, so we've actually got x squared minus 3x over 5 plus x. Man, that's pretty much it. There's nothing we can do. They do not have any common factors. All right. Now, these are a little bit more challenging. These are composite functions, functions of functions. And sometimes they're more straightforward than others. But the most important thing is to remember how to operate these. F of g of x, for example, means we take f of x and we literally replace each x with a g of x. All right, so because f of x is 2x squared minus 5, that x is being replaced by g of x squared. So I'll have minus 2x plus 7 squared minus 5. Okay, and of course, this is g of x minus 2x plus 7. Now for that, we can do a FOIL, or you don't have to do a FOIL. You can also write it out the long way. Let's do that this time. So you've got 49 minus 14x minus 14x. And here you've got positive 4x squared. All right, so what does that leave us with? (4x squared) minus 28x plus 49. Okay, so all of that goes inside these parentheses. Okay, so there's minus 2x plus 7 squared is what we're seeing here. And then you just multiply out the 2. Okay. All right, this should do that one. Now what do we have? All right, so let me actually split the screen again so we can see what we're doing. Yeah, so we have to be able to see these two. Otherwise, it's going to be a bit of a problem. For example, g of f of x. Okay, so here's what's happening now. We take the function g of x and replace all the x's with f of x. Okay. So inside parentheses, we have f of x, which is 2x squared minus 5 plus 7 minus 4x squared plus 10 plus 7. And we ultimately end up with minus 4x squared plus 17. All right, what's next? F of g of 0. Okay, so these are a little bit simpler because you can reduce one of these to a constant. So why don't we do this? G of 0, since g of x is minus 2x plus 7, g of 0 would therefore be minus 2 times 0 plus 7, which is 7. So this is equal to f of 7. All right, which is easy because then you take your f of x equals 2x squared minus 5 and just simply replace the x's with 7's. Okay, and that's going to give us $93. Nice. Now we'll do the opposite here. G of f of 3. So first we want to solve for f of 3. So since f of x is 2x squared minus 5, that means that f of 3 must be 2 times 3 squared minus 5. Okay, and then we'll have 2 times 9 minus 5, 18 minus 5, which is 13. Isn't that right? Hold on. Did I do this right? Oh, right. Yeah, but we're not done. That is correct, but we're not done. Okay, so g of f of 3 is equal to g of 13. And since g of x is minus 2x plus 7, that means that g of 13 is minus 2 times 13 plus 7 minus 26 plus 7 minus 19. Excellent. Now f of f, this means f of x, by the way. It's just shorthand. So that means you go back to f of x, which is 2x squared minus 5. And now, wherever you see an x, you replace that with f of x. Okay, so you've got 2, f of x is 2x squared minus 5 squared minus 5. All right, well, we can do a FOIL on this. Okay. F O I last. Okay. Well, that got a little sloppy, but that's all right. Let me fix that. Okay. As long as you can see this part, should be okay. All right, so you end up with 4x to the 4th minus 20x squared plus 25. Now that still has to be multiplied by 2 and subtract, we have to subtract 5. So 2 times 2x squared minus 5 minus 5. Therefore, it equals 2 times 4x to the 4th minus 20x squared plus 25 minus 5. So you're going to have 8x to the 4th minus 40x squared plus 50 minus 5. And then finally, when all the dust settles, this is our final result. Okay. And then one more is g of g. Yeah, that's it right there. So this is the same thing as g of x. So that means you take all the x's and replace them with g of x. So you're going to have 2. Let me just, oh, there it is. Okay. 2 times minus 2x plus 7 equals minus 4x plus 14 plus 7. And that equals minus 4x plus 21. I think, wait, did I do this right? No, sorry. You know what I just realized? This was a negative. No. I knew something was wrong. Let's try that again. That's better. 4x minus 14 plus 7, 4x minus 7. Much better. Okay, fantastic. All right, now these, we can show their inverses. So here's what I have to do though. Again, because I'm concerned about the space, there's only so much you can store on one of these Word documents. And once you get past that limit, well, let's just say it gets ugly. It's very difficult to fix the problem when you have too much in there. It starts to refuse to do anything. So what I'm going to do is go get this and save another copy of it. So the worst thing that can happen is we have two copies of it. In other words, the solutions are in 2 halves. All right, that should take care of it. So we're going to start with 23. Just save this one more time. Yeah, it was getting close. All right, but now we should be okay. So the second part will be right here. We'll start down here. All right, so remember now, how do you do this, by the way? F of x, g of x. So the definition or the way we do this is to show that f inverse of x equals f of inverse of f of x, which is x. Now here we're calling them f and g. So you would call it f of g of x and g of f of x. Either way, they both have to equal x. All right, so how would this go? So actually, let me split the screen. And so let's start with f of g of x. So you're going to have 1 over g of x minus 4. Because the original function is 1 over x minus 4, you replace the x with the g of x. And then you'll have one over, and now here you can put in parentheses 1 over x plus 4 minus 4. All right, so drop the parentheses. So you've got 1 over x, which is the same thing as 1 times x over 1, which is just x. So that condition has been met. We're good there. Now we got to try g of f of x and see if it also works. So that means you're going to have 1 over f of x plus 4. And that will leave us with 1 over x minus 4 plus 4. but 1/1 x minus 4 is the same thing as 1 times x minus 4/1. And that in turn just equals x minus 4 plus 4 equals x. Okay, so both conditions are satisfied. Therefore, f of x and g of x are inverses of each other. Perfect. All right, so that one's done. How about 24? Okay, so we'll start with f of g of x. Three g of x minus 2 is 3. The 3's cancel out. You're left with x plus 2 minus 2, which is just x. All right, so that one's fine. Now, how about g of f of x? You'll have f of x plus 2 over 3, which equals 3x minus 2 plus 2 over 3. 3x over 3, or just x. Perfect. That's it. That one was nice and easy. So you can conclude that just by saying both conditions are met. Therefore, f of x and g of x are inverses of each other. All right, now let's try this one. F of g of x is 4 minus 4gx, g of x. These 4's cancel. You'll get 4 minus 4 plus x. All right, that one's easy. G of f of x is 4 minus f of x over 4. Okay. 4 minus 4 plus 4x over 4. Ah, this one works too. Beautiful. All right, so once again, we conclude that both conditions are met. Therefore, f of x and g of x are inverses of each other. Perfect. All right, one more. And here we have, let's see. F of g of x would therefore be 2 plus 1 over g of x, or 2 plus 1 over x minus 2, which is 2 plus x minus 2, which is x. And then when we work it backwards, g of f of x 1 over f of x minus 2, 2 plus 1 over x minus 2. So we have 1 over. Now, when you drop these parentheses, you'll just end up with 1 over x, which is just x. Okay, great. Okay, therefore f of x and g of x are inverses of each other. Perfect. All right, and that's what we set it out to prove. All right, now evaluate. Of course, now here we're evaluating with imaginary numbers, so we have to remember the rules. Specifically, the exponents of I will help us very much in these cases. So for example, here we'll have f of x is 2 times 2i minus 7 squared plus 3 times 2i minus 7 minus 4. So the tricky one is the first one because it involves FOIL. So let's apply FOIL here. Four I squared, 14, negative 14i, negative 14i again, positive 49. So when you consolidate these, you have 4i squared minus 28i is 49. But remember, I squared is negative 1. Which means that we have 4 times negative 1 minus 28i plus 49 minus 4 minus 28i plus 49. So you have minus 28i plus 45. But that's just this part. We're not done, not even close. And so we're going to end up with, let's split the screen. Two times f of x therefore equals 2 times minus 28. Oh, I left out the I there. No, sorry, it's okay, hold on. The I belongs over here. It's minus 28i plus 45. All right, so we'll put that in here. That takes the place of this 2i minus 7 squared. Then we, hold on. Okay, then, okay, so we have the negative 28i plus 45 plus 3 times 2i minus 7 minus 4. All right, well, now we just multiply minus 56i plus 90 plus 6i minus 21 minus 4 minus 50i. Now, if you add these up, this is actually 90 minus 25, which is 65. And that should be the final answer. Okay, let me just double check something. Yeah, that's it. Number 28. This one's a little quicker because you're just evaluating f of I, but this is the one that gets us involved with these higher powers of I. Okay, so why don't we run through this one more time? So I squared is -1. I cubed is -I. I to the 4th would therefore be 1. And I to the 5th would just be I. So you just end up with I minus 2 times -I. So when you're finally done, you're just going to wind up with 3I. Okay. Now 29. Now with division, it's going to get a little bit messier, but we may be able to use complex conjugates to simplify it. So let's see, we'll have f of 6I is 6I squared, quantity squared, minus 2 times 6I plus 1, all divided by 2 minus 5 times 6I. So here we have 36I squared minus 12I plus 1. Down here we have 2 minus 30I. Now, let's not forget that I squared is -1. So that should simplify it a little. All right, so I've got minus 36 minus 12I plus 1 over. Now, let's rewrite it as minus 35 minus 12I over 2 minus 30I. Now, here's the thing. Now, that is not wrong, but we know that by convention, we try to avoid having imaginary numbers in the denominator. Okay, so what would we do next? Just to make it a little neater, let's say. The complex conjugate of 2 minus 30I is 2 plus 30I. And so when you multiply those out, now in the numerator, now in both cases you can use FOIL. Okay, so in this case, let's see what you get. All right, here's the first, minus 70, outer. So 30 times minus 35 is minus 1050. Minus 1050I, that is. Inner is here, minus 24I. And here's last, which is minus 360I squared. Wow. This is going to be a bit of a mess. But that's all right. We can do it. So that numerator is minus 70 minus 1050I minus 24I minus 360I squared. So we can consolidate these two. But of course, we know that I squared is -1. All right, so finally, the numerator is seen to be 290 minus 1074I. What about the denominator? 2 minus 30I. Let's try that. This will be our denominator. Okay, 2 minus 30i times its complex conjugate, which is 2 plus 30i. All right, let's see what we get. Or 60i minus 60i. Ooh, not negative 900i squared. These drop out. This becomes negative 1. All right, then. So the final result is that f of 6i, okay, f of 6i is 290 minus 1074i all over 904. Okay, and now that's as simple as it's going to get. So you can stop. I mean, it's not theoretically impossible, that there's still some more simplification you can do. It doesn't really look like it. If they were all factors of 2, for example, you could take it a little further, but basically you're done. All right. Now this next one, well, I guess we're going to run into the same thing, except, wow, this one's got a cube in it. Oh, that's going to take a while. All right, well, let's give it a shot. All right, what do we have here? 1 plus 2, 4i plus 9, minus 3 times 4i plus 9 squared. All right, here we've got, wow, 4i plus 9 cubed plus 3. Well, all right then. I guess we'll split. And let's take it from there. So for the numerator, we do need this 4i plus 9 squared, which we can use FOIL with. All right, so if we do, (16i squared), 36i, 36i again, 81. Actually, we don't need to split it any longer. Hold on. All right, so now, of course, we know that I squared is negative 1. Oops, hold on. All right, so that would take care of this term. Here we go. Okay. So the numerator would be 1 plus 2 4i plus 9 minus 3 times this, 65 plus 72i, 1 plus 8i plus 18 minus 195 minus 216i. All right, so the constants, when we combine these, we have 19 minus 195, negative 176, and then minus 208i. Now, here's the fun one, the denominator, 4i plus 9 cubed. Now, as it turns out, though, since we already know what happens with 4i plus 9 squared, so here's what we can do. We can take advantage of that. Four I plus 9 cubed obviously equals 4i plus 9 squared times 4i plus 9. But we've already proven from before that this equals 65 plus 72i. So now we can apply FOIL here. And let's see what we get. All right, here we go. So here's F. 260i. There's O. That's 585. I, these two is 288i squared. And then finally, last is okay. So we can combine these, of course. I'll add these together. So we've got 585 plus which of course is -1. All right, so all of that represents, unfortunately, that's not the entire denominator because we had this +3 term. So the final result for the denominator is all of that +3. All right, so I think we got everything we need. So the final answer is, after all of that work, oh my God, f of 4i plus 9 here we have 700 plus 908i. The numerator we determined to be minus 176 minus 208i. Well, we're almost done. I'll tell you why. Because unfortunately, we still have one last detail here, which you know what's coming. It's going to be hold on one second. Let me just double check something. Okay, no, something's wrong right here. Just should have been 297, sorry. Yeah, and then one last detail, unfortunately, you'd ideally, now in a test, you can leave it like this, that's fine. But ideally, what we should do is multiply this by the complex conjugates. And that means oh my God, two more foils. But you know what? It's good practice. Okay, so all right, let's do it. We'll start with the numerator. All right, oh my God, the numbers are going to be huge. 176 times 300 minus 52,800. Oh, 176 times 908. 159,808. I 62,000, negative 62,400. And then last, negative 208 times negative 908. Wow, 188. 864 I squared. Well, all right then. Oh, I left out the I here. All right, now we're good. 52,800. So I'll combine the two I's, 159,808 minus 62,400, 97,408 plus 188,864 I squared, which is negative 1. So you end up with negative 241,664 plus 97,408 I. Now, the denominator, though, at least will turn into a constant. All right, so it's 300 plus 908 I. Let me move that. So 300 plus 908 I and 300 minus. Okay, great. All right, so when we do the FOIL here, it'll turn out to be a constant, which speeds things up a little. All right. 90,000, that's FO. 272, negative 272,000. 400I. The inner is just the same except for the positive sign. And then last, $824,000. 464, but that's I squared, of course, which is -1. Okay, so that gives us, in our denominator, minus 734, 464. So finally, we can bring all this together. So there's our denominator. The numerator was, I now forgot, it was such a long time ago. Here it is. Okay, there you go. Well, that was a lot of work, that's for sure. Let's say that we'll try to keep these off the actual test. How about that? Yeah, because you've only got so much time. All right, now here's some more. Now, of course, we've already covered a lot of this, but again, it's good practice. So like here, for example, we have FOIL, but we're going to still end up with higher powers of I. So let's see how that works out. (12i) for F, O is minus 3I squared. I is positive 32I squared. And then the last one is minus 8I cubed. So we'll consolidate these to give us 12I plus 29I squared. So just remember, I squared is -1. I cubed is -I. Now, that wasn't that bad, was it? It was not, except you have to be careful recognizing the higher powers of I. That's really the only challenge here. Very good. Wow, let's see how much is left. Ooh, there's a lot. Okay. Well, we're not going to finish this tonight, that's for sure. But what I think I'm going to have to do here, save it one more time. This one I might have to split up into 3 pieces just because it's such a massive document. Now let's do this. Okay, good. So we'll start with 32 here. All right, so once again, we'll apply FOIL. oops. (12i cubed minus 18i to the fourth. Inner is these two, minus 6i to the fourth. And then last would be 9i to the fifth. So first I'll consolidate them. All right, so why don't we go through our list again? I squared, I cubed is negative I to the fourth is 1, and then finally I to the fifth is just I. So we're going to have 12 negative I minus 24 1 plus 9i. So we'll have minus 12i minus 24 plus 9i. Finally, when we're done, minus 3i minus 24. All right. Now, how about this one? Oh my God, look at the size of those exponents. All right, well, let's do it. F is 16. O is 8i cubed. I is minus 8i to the fourth. And last is minus 4i to the seventh. Wow. So let's see, 16, there's not much to consolidate. They can't be combined. Let's go back to this list again. Yeah, we didn't even get that far. I to the sixth is going to be I squared. Let's see, yeah, I squared, which is negative 1. And then I to the seventh is going to be negative I. So remember, they cycle through I, negative 1, negative I, and I to the eighth would just be 1 again. So it's like a cycle. Every 4 are the same. Okay, so what do we have here? So 16 I cubed is negative I. I to the fourth is 1. I to the seventh is negative I. All right, so when we're done, it'll be not that complicated. Surprisingly straightforward, considering what we had to go through to get to this point. Now, these are, of course, division, which means we will almost certainly need to get involved with complex conjugates. All right, here we go. So we'll take this one. And the complex conjugate for 2 minus 4i is 2 plus 4i. Okay. All right. So we'll start with the numerator. Six 12i. The inner is 10i. And last is 20i squared. Okay. All right, so 6 plus 22i plus 20i squared. 6 plus 22i plus 20 times -1. -14 plus 22i. That's the numerator. All right, hold on. The denominator is right here, 2 minus 4i, 2 plus 4i. All right, so here we go. 4, 8i minus 8i, -16i squared. These cancel out. All right, so when we're done, we have -14 plus 22i over 20. Now this time, it's pretty obvious that we can divide out by 2 in all of these cases. So we'll just end up with -7 plus 11i over 10. All right, now how about this one? All right, so in the numerator, we can apply FOIL. We can't do that in the denominator. All right, so what do we have? FOIL 15 minus 10i squared, 3i minus 6i cubed. All right. So we can, well, we can't actually do anything with these except make some substitutions. All right, so what does that leave us with? So 15 plus 3i plus 10 plus 6i. So yeah, we end up with 25 plus 9i. This is the numerator. Now, the denominator is just 1 plus I cubed, but remember, I cubed is -I. Okay, so this can be rewritten as 1 minus I. Now, here's the thing though. that means that the final result is 25 plus 9i. But you know what that means? Once you get to that point, I better double check this. 15. Oh, I don't know what happened here. Why did I make this 6? This is 2. Yeah, I knew something was wrong. All right, hold on. Let me fix this real fast. Yeah, okay. So that was wrong. This is 5. All right, as I started to say though, so you have 25 plus 5i, as it turns out, over 1 minus I. But now that it's been simplified, you can actually now apply the complex conjugate to it. All right, so let's do that. All right, so let's see. So in the numerator, $25, $25i, $5i. Now this is 5i squared, of course, which reduces to -1. So we've got 25 plus 30i plus 5i squared Okay, so that means we have 20 plus 30i. That's our numerator. And then the denominator, 1 plus I, 1 minus I. All right, first is I, 1 rather, negative I, positive I. All right, so we'll have 1 minus I squared, 1 minus 1, which is 2. So now we finally bring them together. The final answer is 20 plus 30i over 2, which is, of course, 10 plus 15i. So that time it really did get a little simpler, didn't it? That's kind of nice. Okay. Well, so there's just one more, and then we're back to vertexes. How do you like that? We've made a complete circle, 180 degrees. So, so we'll apply some FOIL to the numerator. 1 plus 3i, 2 minus 4i, two minus 4i, 6i minus 12i squared. All right, so you have 2 minus, or plus 2i rather, minus 12i squared. That's my numerator. And my denominator is 1 plus 2i, 1 minus 3i. All right, we'll apply FOIL here. One minus 3i, 2i, and negative 6i squared. Okay. That's your denominator. Now we can just put them together. What do we have? 14 plus 2i. 7 minus I. Oh, guess what we still need to do? All right. That's fine, but we really should apply the complex conjugates. To get it as simple as possible. So for our numerator, um, 14 plus 2i, 7 plus I, 98, 14i, 14i, 2i squared, okay, so we're almost there. 96 plus 28i is the numerator. And of course, in the denominator, it's 7 minus I, 7 plus I. $49 minus 7i plus 7i, minus I squared. So a 50, and that means that when the dust finally settles, the simplest version is 96 plus 28i over 50. And then you can simplify if you want. I mean, let's face it, there's probably multiple simplifications that are still possible, but I think this is as far as we can take it. 48 plus 14i all over 25. That should do it. All right, so what's left is the stuff. Actually, this is everything we were just doing before. So maybe what we'll do is we'll save this for next time. Well, there's some basic ones down here as well, but we can finish these. I'll tell you what we'll do. Under the circumstances, let's save the midterm for not next week, but the week after, so that we can go through this one more time if necessary, and then we can finish it up because we still have all of this to go. And it would be nice if we could be there in person so you could ask questions. So here's what we'll do. We'll finish this up next week. Then we'll get back to chapter 4 and start 5, which, by the way, involves trigonometry. And your old friend trigonometry, yes, I know. And then the week after, we can have the midterm. Okay. So what I'll do is now it's not completely done, and you can see the solutions have been broken up into multiple parts. I'll post all of these on Moodle, and then you can go over them at your leisure. Also, this video I'll make it available on my YouTube page because there's not enough room on Moodle apparently to store videos. So you can go look at it. Let's see, let's go look at YouTube for a second. So I have a ton, and I mean a ton of videos here. Here it is. Well, here I just call it A, but if you type in my name, you should be able to find it. So there's a bunch of videos. Ours will be listed on, I'll set up a playlist for us. And because there isn't one just yet. So yeah, and you'll be able to find it there and you can watch it at your leisure. All right, so other than that, I think we'll knock it off right about here. And so remember, next time we'll finish this up and then we'll do the rest of 4. We'll start 5, answer any last minute questions. And then this way we can have the actual midterm the week after. Okay, there's no rush because your spring break is not coming up anytime soon. So, all right, so I guess I'll see you next time in person, I hope, if the weather is a little bit better. So, all right, good night.